Are we there? I think we're there. Thank you very much for that. Thanks for
Very
the
good.
introduction. Very pleased to be with you here with you and this really varied panel today. So to start the panel on the importance of climate services for energy systems in the water sector, I'd like to introduce our first speaker, Dr. Sue Hapt. So Dr. Hapt is a NCAR Senior Scientist and Deputy Director of the Research Applications Laboratory, RAL of NCAR. She leads projects in renewable energy prediction, coupling mesoscale models to microscale models, and in applying artificial intelligence. She is a fellow of the American Meteorological Society and contributing and founding director of the World Energy and Meteorological Council, WENSI. Dr. Hapt is an expert in a lot of things. There's a long list. Applications of artificial intelligence in the environmental sciences, boundary layer meteorology, large-scale atmospheric dynamics, renewable energy, dynamical systems, numerical methods, and computational fluid dynamics. So it's great to have her here today. Dr. Hapt has published books as well as many journal papers and book chapters in the field. So over to you, Sue.
Thank you. Can I share my screen here?
I believe so.
Yes.
Yes, go for it.
Great. Okay, I'm really pleased to be here. Of course, in the U.S., it's just getting to be reasonable time in the morning, but thrilled to be able to participate in this SECLI-FIRM summer school. The first point I wanted to make is about the variability of the atmosphere on climate scales and on global scales. We know that the atmosphere varies highly. Here is a simulation from the Community Earth System climate model where you can see all the changes that go on, in the course of a day, a month, a year, a season, etc. But then the energy from the large scales impacts the continental scales with the weather systems that pass through. Now, if you're talking about wind energy, then that also impacts, of course, the wind plant scales. But we have to remember it's not a consistent flow. Things like frontal passages make for rapid changes in this variability. And of course, that in turn impacts the wind turbine itself and the way it harvests the energy. Now, this cascade of energy from the large scales to the small scales is critically important to being able to harvest renewable energy. But the turbulence at those fine scales again feeds up and modifies what's happening at the largest scales in turn. So to be able to best use renewable energy, whether we're talking about wind, solar, hydro, we need to be able to forecast that atmospheric variability on a range of scales. And when we talk to the utilities and the TSOs, the things that they care about really are the hub height wind speed, the solar irradiance, the stream flow, but really the power that comes from it. And they're interested in being able to forecast it on a variety of ranges. The nowcast range in the next few hours, how are they going to run the grid as things are changing dynamically? We usually use 15-minute forecasts for those. Then
no, I'm really sorry to interrupt you. I'm so sorry. We don't see your slide. I don't know if you changed it or still didn't change it, but I think we're not seeing you change your slide.
That's too bad. I put it on the other screen. When I put it back on the first screen, are you seeing it again?
Now we see it. We see the
Okay,
animation.
I'll have to leave it on this screen
and
not look at that then. So that's good. So hopefully you saw a little bit of these simulations and that variability that comes and cascades back up. But this need to be able to predict that variability over a lot of ranges, the day ahead range for planning, day ahead allocations, the longer ranges, seasons, weeks for planning, maintenance, distribution, and very long ranges to decades for resource allocation planning. Now, here at NCAR, we're a research lab, but we've worked very closely with multiple clients to build forecasting systems, primarily on the nowcasting day ahead, week ahead ranges. And for a while, we worked with the Solar Energy Technology Office of the Department of Energy and developed a solar power forecasting system with a lot of collaborators, other national labs, universities, utilities, TSOs, forecast providers. And when you're talking about solar energy, you can think in terms of a value chain, where on the left, weather happens. And for solar energy, that's clouds and aerosols. But where we want to get to is providing economic and social value. So we have to be able to predict, the production chain, the changes in production costs, analyze the reserves. And to do that, we move across this chain, looking at different types of monitoring that can be done, modeling, forecasting, turning all that into a real forecast, disseminating that to the user, and thinking about how they're going to perceive that and how they're going to change their operation so that they can do this day ahead planning and real-time operation and make the changes that will add value. It means everybody working together, not just the person building the forecast, but really working closely. And we used some social science methods to be able to get to the place we were. Now, when you're doing forecasting, it requires understanding the type of modeling you can do, physical modeling on each of these scales, from the real in situ observations that give situational awareness for now to satellite-based methods, numerical weather prediction. There's a host of different types of numerical weather prediction on up to seasonal modeling. And what I didn't include was the climate modeling as well. But one way to tie this all together is with machine learning. And when one builds a system, the idea is to blend the most important elements for your time range, convert to power. Very important to quantify the uncertainty so that you can make probabilistic power predictions on the right range for the needs. When we did that for solar power forecasting, we built a system with lots of physical models as well as AI models that are outlined in red here. We also have built a system that includes both physical models outlined in blue here, plus AI models that does both wind and solar forecasting for Kuwait, where they're developing plants that do both. Now, when we think, as we're moving forward, we're just really beginning to build systems like that for combining the modeling with the machine learning for the S to S prediction scales too. And I did want to show some really interesting work based on NCAR's Community Earth System model. They have built a large ensemble that covers 85 years. When you use that amount of data, you have enough data to be able to predict for seasons. And this is work done by a group at University of California, San Diego, including by Will Chapman, who's soon going to be a postdoc with our group. They did some really interesting work where they used EOFs to identify the right predictors for both the ocean, the SST, and the atmosphere, did clustering, then applied multiple machine learning methods to the 4 different clusters. And when they got the results, they found that the machine learning methods based on this climate model data were as good or better than some of the best ensemble members that methods that are being used across North America, including the multi-model ensemble. So we see a lot of possibility going forward, as you're going to see in a lot of these SECLI-FIRM lectures over the next couple weeks. And you'll see other examples. But the thing I wanted to really point out is that climate services for energy really is important for integrating variable renewable energy, and combining machine learning with the physical models has become state of the art, not using just one or the other, but really doing a combination. We're seeing some promise at the subseasonal to seasonal scales now, and that machine learning really is not just a black box. We can start using interpretable or explainable AI these days as well. So again, the message being that using a blended physics AI approach to science does help advance our applications on many of these problems, including in energy systems. Thank you.
If we were allowed, thank you very much. I was just coming in to ask if we could move along to the conclusions. That's great. Thanks very much to Sue for a really interesting talk there. If I could remind the participants that if you'd like to ask Sue a question, then you can pop it into the chat, and we'll try to make time for a question and answer session at the end. So moving on to our next speaker is Laurent Debout. Laurent is a lead scientist in weather and climate at RTE, that's the French transmission system operator. He's been working long-term power system evolution and resilience to climate change and short-term forecasting. He's a founder and non-executive director of the World Energy and Meteorological Council. He has skills and experience in climate system modeling, weather and climate forecast, power system management, and climate service design and development. His activities are dedicated to improving the effective integration of high quality weather and climate information into energy sector planning, risk management, and operational activities to better manage the power system on all timescales. He holds an engineering degree at marine environment and a PhD in physical oceanography. So welcome, Laurent. Laurent, we have about 7 minutes for each presentation, so over to you, please.
Yeah, thank you, Emily. Hello, everyone. Can you confirm you can see my slide there? Okay, thank you. So it's always difficult to speak after Sue because our presentations are so outstanding, and thank you, Sue, again for this very nice overview. So I will, despite the little bit high-level title here, I will be very pragmatic and just try to deliver one key message at the end of my presentation. So what I'd like to address is the usefulness of climate services for the energy transition. And yeah, you just can remember the last summer, and clearly we have a problem. Of course, not the extreme events we experienced this summer can probably be attributed to climate change, but it's most likely that many of them can be attributed. So we're talking about fires, heat waves, droughts, flooding, and so on and so forth. So we clearly see an increase in the occurrence of such events, and we clearly need to do something. For the energy sector, this means that we are facing a very difficult period in the next decades with a really necessary energy transition. This transition first means energy sobriety. By sobriety, I mean that we need to reduce our energy consumption, or at least the energy consumed per unit of GDP or whatever you want. This also means that we need to decarbonize the energy generation. Electrification is a very good mean for that because it's very easy to decarbonize through electrification, and electricity generation can be done without fossil fuels quite easily from the technical point of view. And it includes, in particular, the development of renewable energies. So wind and solar, first of all, but also biomass, marine energies, and so on and so forth. So the path is clear for the electricity sector, but the way to reach it is not that simple. Anyway, this means that energy systems are becoming more and more dependent on weather and climate. And so weather and climate services are really becoming more and more important. And I just want to say that because it's also to emphasize the great usefulness of this summer school and the hopes that we can put in all the people who are committing to work in this area. And I'm very happy to see such a large audience today in this summer school. Then I was asked to say a little word about my personal journey through the climate services landscape. I must say that I was lucky enough, and even very lucky, to be part of most of the projects that were that happened in Europe in the last 10 years or so about climate services. So Carlo already talked about the Euporias project, which was, I think, one of the first ones back in the early 2010s. Then there was the climate services for clean energy, so S2S4E project, and different projects within the Copernicus Climate Change Service. So there were two proof of concept, ESM and Clean for Energy, and then the operational service for the energy sector that Alberto led. And I must say, even that in my previous affiliation, so working for EDF, the largest electricity company in France, I had the opportunity to contribute to an internal climate service that was developed within the company to add some bricks on top of what was available in the public landscape. Carlo already showed that picture, and one of the most interesting things I kept from the Euporias project was really the fact that the user interaction process, user listening, and the co-design and collaborative approach really was developed, I think, starting in Euporias. And this again was something that came from the kickoff meeting of the C3S ESM workshop that was in 2015 or 16, I don't remember exactly, but yeah, this really was one of the key outputs that to build a climate service, we need to know who the users are, we need to understand what they are expecting, how they work, who they are, and so on and so forth. And so my main message is that climate services is, on top of all, I think, a matter of partnerships, of collaboration and discussions between both communities. So the climate scientists on one side and the end users on the other side. I would even go further by saying that this includes bi-directional training between those both communities, because both can learn from each other, and that's extremely important. Of course, the climate scientists can bring knowledge and tools and products to the users, but the users can also help the climate scientists better understand the needs, the societal implications, and so on and so forth. And so, yeah, only one keyword: partnerships.
Thanks.
Last
Thanks very
but
much,
not least, yeah, last but not least,
last slide.
Yeah,
thank you.
Yeah, I would just like to emphasize the fact that visuals are extremely powerful in that journey between scientists and users. Thank you.
Great. Thanks very much for that. It's so much experience coming from Laurent. Thank you. And I don't know how many people noticed the guest appearance from my mother. I don't think it was billed, but it's just a little bonus for you. And I now have a cup of tea. So thanks for the presentation, Laurent. Our next speaker is Antonio Nicolai, who's had a really varied career as well. Pleased to introduce him. So during his studies in 2014, Antonio was involved in a geothermal project called Hot Earth for 2 months, and he worked in a HVSR survey on the top of Etna volcano as a field operator. In 2018, he obtained his master's degree in exploration and applied geophysics at the University of Pisa in Italy, with a thesis on implementation of near-surface top soil temperature survey and its application in the Caninci Pagenzia test site. So apologies on the pronunciation there on that one. After graduation, he worked as a field geophysicist in 2 mineral exploration projects, Alta Zinc project in Pianbarca and in Hawaii for golden and minerals in Turba, Saudi Arabia. In January 2020, he joined Enel Global Trading, SPA, where he currently works in the SECLI-FIRM team as a data scientist and support to the weather group. So welcome, Antonio.
Thank you, Emily, and it's a pleasure to be here in this summer school. During my presentation, I want to share with you some important aspect and milestone of Enel experience with the climate service, and in particular with the SECLI-FIRM project. And as you probably know, Enel is a multinational company in the energy sector with a particular focus on electricity and the gas market. And our vision is strongly sustainable. As you can see in our motto, we empower sustainable process. And in this slide, I put a little bit of story of our company, but I want to focus your attention in the exploration of alternative source of energy and in the decarbonization plan that we started in 2015. And our goal is to complete a total decarbonization by 2050 agree with the Green Deal. Of course, this change in paradigm has led new challenge and issue, one in particular. And I talked about the weather exposure. In fact, if a company produces 100% of its energy from renewable resource, can be also affected by a strong variability of its production, and is due to the weather events at a different time scale. In this slide, in fact, you can see how a single event starting from a lighting from a few milliseconds to very long-term change, for example, El Niño, can be led an impact on the market. Alberto already showed this slide, but I want to repeat the concept. In fact, below in red, you can see each impact in the energy sector as consequence also in the market. And you have to think that for a management months in advance, the most important are the medium and the long-term phenomena. I want to underline the importance of an energy company to have a plan for the future. Now here, I want to show again a real case of extreme event occurred in 2015, and that several of my colleagues remember very well, because it brought a strong impact in the market price. And this strong event was characterized by heat wave and led to produce anomalies up to 7 degrees. This is all on over Southern and Western Europe. And in this case, the power demand reached very extreme values too, due to the massive installation and use of air conditioning system. So all the system was forced to produce with other thermoelectrical resource. Now I want to focus your attention in the graph on the bottom right. That represent how was the forecast for the power price for July. In fact, the blue line represent the price for July seen from January, February, etc. And in the first part of the year the price is normal. When July comes, you can see a very high in price, and this graph means that this increase were not properly forecasted in advance. From this is built the necessity to have more knowledge on seasonal forecast. And at this point, you have to manage the situation in this way. From one side, the scientific world made by professors, researchers, PhDs, etc. And from the other side, an energy company. I use these comics as a joke, but it's just to stress the concept. So these two worlds are complementary, but they work in different ways and not always in the same direction. And in this context, a very important mediation table was, for Enel especially, was the SECLI-FIRM project. In fact, in the first most important goal was the possibility to have knowledge of seasonal forecast and the practical needs of energy company into the same table. This seems trivial a little bit, but is not at all, because these two words sometimes speak different language, and SECLI-FIRM helped in this as well, because we're starting to speak the same language at the same table. So at this point, I think the why of SECLI-FIRM is clear, because of course this project can keep the focus on seasonal forecast and help the decision-making process within a company. But another important aspect was the how. We had a multitude of meeting, conference, roundtable, and in general webinar to discuss the best way to apply the seasonal forecast and their probabilistic information within the decision-making process that work with a deterministic approach. To make it applicable to all cases, we also produced a decision tree, making tree, that Alberto shared before, that schematized the choice to be made in the company in case of extreme event. And now we move on what in particular was the focus of the project. Alberto already says also this, but Enel in particular analyzed the 5 case studies, 1 to 5, 3 in Italy and 2 in Spain and Colombia, all characterized by extreme weather event. And we tried to understand if the use of seasonal forecast would bring added value within the company. This project was 42 months long, plus an extension due to COVID-19. We'll end next month. This makes it possible to share the know-how of seasonal models from research to industry, and from other side, our economic models from industry to research, as well as increasing the synergy between the two words mentioned before. And so for Enel, what are the lessons learned? First of all, we were backtester of seasonal forecast, and we acquired the knowledge of seasonal forecast and their integration into our econometric models and business models. We also learn how to use functional tools for weather risk analysis, and we improve synergy with the other projects in the same direction. Last but not least, we were able to recruit a new resource from a very different background, like me, to work on the SECLI-FIRM project. And here in my last slides, as you can see, is our team in Enel. We all worked on the SECLI-FIRM project, and it is thanks to this project that this highly qualified and close-knit team was able to form. And I would like to end my presentation like this, thanking you and underlining how the formation of a specialized team within a company like Enel is itself an added value. So thank you for your attention, and I hope that you found it interesting. And I hope also I respect all the time.
Yes, so yes, we'll stick to the speakers having their allotted time now, and just squeeze the Q&A slightly to make room. So thank you very much for sticking to time, and that's a really interesting seminar about the cross-disciplinary working that's been needed for the climate services in NL. So our final pair of speakers are joining us from Thames Water. So we have Ian Savage and Leo Kernman. It's Kernan, apologies. Ian has worked in the water industry for 30 years. For much of this time has been focused on the ability of forecast demand for water based on weather forecasting, specifically to optimize production plants output and plan asset outages for maintenance. We're also joined by Leo. Leo has spent the last 22 years as part of Thames Water Innovation Team, focusing on ways to use data to generate information and actionable insight. He leads a team providing evidence-based decision support services. The support has included understanding how weather patterns impact demand for water and how that demand might change over time, and how interventions taken by the water industry may moderate that demand. Leo has a PhD in practical use of machine learning, and before working in the water industry, spent 3 years working with Takehome, helping develop their advanced telemetry and data acquisition systems. So over to Ian and Leo. If you could stick to 7 minutes, that would be really helpful, and then we'll get on to some really interesting Q&A with the panel as well. Thank you.
Sure thing. Just share now. So hopefully you can see my presentation. Is that good?
Not yet.
Excellent. Are we there? Oh, that's interesting. Okay, how about now?
Now we can.
Good, thank you very much. Okay, so I'm going to start by, I'll do most of the talking. So between myself and Ian, we've probably got 50 years worth of experience of trying to understand how the weather affects the water industry. And it does affect a huge range of aspects of the water industry. In this summer school, we're going to focus on only one aspect of it, about how weather affects the demand for water. But this diagram I'm showing here shows that the water cycle is kind of integral to a huge part, or every corner of the water business, really, from how much water is available in the environment for us to abstract. And we need to manage that carefully, because part of our responsibility is to take care of that water in the rivers and in the aquifers. We've got to then take that water and clean it up and make it fit for drinking, and then we've got to supply it to users, like everyone on this call. And of course, everyone on this call will use a different amount of water each day, probably depending on what the weather's like on that day. And then we've got to return that water and that waste back to the environment, and the quality of that stuff that we return back to the rivers and back to the environment is also a function of the weather. So it matters on the very short term, if it rains very heavily, or if it's very sunny today, for instance, and it matters on the long term about climate change and droughts and the longer patterns of water availability. So I'm going to talk a little bit in detail later on in this series about how we've used the climate services that become available in SECLI-FIRM. But for now, I'm going to talk about our journey, myself and Ian's journey through the world of what's possible inside weather. So yeah, I hope you enjoy the rest of your summer school. So for now, I'm going to start way back in 95, 96. This is before I joined Thames, actually, while Ian was doing his thing. And we really began to try to understand how weather affect usage of water, which is basically the amount of water that I might use when I turn my tap on, or you might use when you water your garden, whatever it might be. And we found that obviously in the very short term, the weather mattered a great deal. So we began to use weather like it was just something that someone could tell us. They could tell us what the temperature tomorrow was going to be, and whether it was going to rain, etc. And we used that to our advantage to understand peaks and troughs in demand, and to allow this planning for production. And then for a few years, we also have a concept of leakage. So usage rises in the summer in the UK, and leakage rises in the winter in the UK. But both of them rise because of the weather, when it's hot and dry, or when it's very, very cold. And so we were building internal models of weather, and that we could then extend that to extreme weather events and very long-term weather patterns like droughts and drought modeling, because we ended up having a drought in 2006. The water resource, it stopped raining for a year and a half, pretty much, and we got into an extremely sharp water resources situation, but the models that we had developed and the weather that we had gathered helped us understand these extreme conditions. That was great. But then we began to build a more meaningful relationship with some of the people who provide the weather data, and that's where the journey became interesting. And around about 2017, it got double interesting because we embarked on this SECLI-FIRM journey into what on earth could be possible, not at the short-term horizons, not on the days and maybe up to a week, but into the sub-seasonal and seasonal horizons, where we could make some pretty big decisions about how to manage our resources. So and that journey has resulted in us as a water company consuming a trial service, which gives us a good handle on what might happen to demand in the next 6 weeks, 7 weeks, 8 weeks, and gives us a really good heads up. It's like turning the lights on your car. You can suddenly see where you're heading and not have to negotiate obstacles as they come into the immediate view. So that's where we're at. We're at this point where we're actually taking a trial service, and I hope we can unpack some of that during the summer school. And we're trying to keep the momentum up on that and bring this story out to the wider UK water industry. There's tens of water companies out there, and turn those things into climate services. So they're really good. My take-home messages are really kind of resonated with Antonio and Laurent, actually. So at the beginning, all we thought was that people could tell us what the weather was going to be like in a few days' time. Okay, and we didn't really realize what the capability was and what the availability of insight and certainty and all that kind of stuff was from the experts in the weather world. So we were trying to think, what could we do with what we thought could be provided? And it turns out there's a whole world of stuff that could be provided, which can actually help us make decisions. On the journey, it became totally clear that we come from different universes. So there's quite different conversations. People talk about climatology and skill and big weather patterns that we kind of knew very little about as an industry. But on the flip side, we were talking about things that mattered, like headroom and outage planning, that probably didn't mean much to the climatologists. So between us, we found a way of just persevering and unpacking what was important in our universe and what was valuable in their universes, and we began to talk a common language in the end. Find a way down the middle that the weather experts can provide insight that could be used by the water people. And the other message is that some of this stuff has gone down avenues expecting to get some output at one end, but in that journey the outputs have changed. So we've moved from kind of very strict interpretations of long-term data to fuzzy interpretations of risk and probability. And in that journey, we've had to find different ways of communicating. So we have to communicate, myself and Ian have to communicate back to the business and unpack some of this stuff. Yeah, some of the visuals and some of the language that have been used, some of the analogies, has really helped to carry the message from the big climate service, big compute world back down into our world where we can apply that. So that's my journey. Thank you very much. If you've got any questions, Ian or myself will happily answer them. But we'll go into more detail.
Yeah, that's a really, really fabulous journey through your journey. Lovely to hear that change of focus, and I think the Met Office, who was on some of that journey with you, would agree with the changes in the way that we're communicating, the way we're able to provide services. So I'd like to move us on to the panel discussion. So thanks very much for all of the speakers for their presentations. We've got a little bit less time than we expected for the Q&A, so if everyone could keep their answers really snappy so we can get through a few different questions and a few different speakers. So I'd like to start with an impression, a question to go around the panel. What were your impressions before starting the SECLI-FIRM project? So if we could maybe start with Antonio, who spoke a little bit about that.
Okay, my impression about the project is, of course, that was interesting project, and also the use of seasonal forecast is something not common in a company. So for me, it was something new. In addition, I went from another type of world. So for me, it was very, very interesting. I hope that I answered to your question.
Yeah, that's great. Thank you. Sue, would you like to give your impressions before you heard about the SECLI-FIRM project, please?
Yes, I've been working with Alberto and Laurent on things like this really over the last decade or so, as we've been forming the World Energy and Meteorology Council. And because I'm in the US, I've been less directly involved, but I've been watching this great SECLI-FIRM project progress, and really glad to see this interaction between the users and the meteorologists and experts. I think that's really the way to advance the use of climate services, is to have this close interaction where it's not just information delivered, but rather it's listening to what the users need and then working with them to design things so that the meteorologist can provide information that is actually needed, not something that goes sideways. So really good to see this project.
Great, thank you very much for that. And Laurent, anything to add on that? I know you've been working with Alberto for many years as well.
Yeah, I can only back up what Sue just told. And I think one of the big good things in SECLI-FIRM is that it was really based on those case studies, trying to really understand specific needs for specific users, as I was mentioning earlier in my presentation. And that's really the strength of the project, to have built something very strong and simply following the learning by doing principle that I think Roberta loves also. It's really efficient, and we can see the outcomes of the project, which are really great. And now all the 9 partners in the 9 case studies, I think, have very good operational services or good mock-ups that can be continued in the future.
So Ian, that same question, we haven't heard from you yet. Did the SECLI-FIRM project look different to things you'd seen before, or was it just an opportunity to continue some of the good work that we've been doing?
Yeah, it was a whole new ball game, a step forward. Looking 3, 4, 6 weeks into the future is something that we'd not done before. But I knew the value that if we could get good climatic services that could give us an indication, it would be a game changer really for the industry, and has already proved on a couple of occasions really useful. The water treatment process is a biological process that is really susceptible to rapid change. So if we know in advance that we're going to get rises in demand, and we can act in a timely manner by raising storage levels and increasing plant outputs slowly and gradually, rather than having step changes, then it's all the better for the process and more optimal, and it's proven really valuable.
Yeah, that's really good to hear. And I know the water industry is quite a collaborative industry. So have you got plans now to what are your plans to sort of share this out to the rest of the industry?
We're working with the Met Office with a demand user group, which involves a lot more water companies in the UK. And the next step at the end of SECLI-FIRM is to find a way that we can keep the service going and then get the service out to the rest of the industry.
That's great. So we had a question in the chat actually about the sort of sustainability of these services, which I think is a really interesting one, that, that it can be the case that funding comes along and, you get a great project going for the duration of that funding, and then the funding's gone. Can you get it to continue? So I know Antonio's already responded in the chat to that particular question. Laurent, I don't know if you've got any comments on that aspect about the sustainability of the services going forward.
Yeah, well, I think that one of the issues in funded projects like European projects, for instance, is that at the end of the project, which means the end of the funding, Often the service is not maintained anymore or not with the same level that it would require. And the great advantage of working with end users like Enel and Thames Water in the case of SECLI-FIRM is that at the end of the project, the service is taken in hands by the user, and it can be sustained with some different funding from the company itself, for instance. And so I think this is really the good approach to ensure that the science that is developed within EU projects or any other result project is maintained in the following of the funding, of the initial funding.
No, that's good to hear. And Leo, I don't know if you want to come in on that as well from the Thames side of things, the importance of that sustainability.
I'd really only be repeating what Lauren said. Really, if you can get the industrial partners in near the beginning, then they begin to scope something that is of practical value. And when it's of practical value, they will miss it when the service gets turned off. And you've got to find this practical way of making the companies something that has value that they will miss if it goes away. And then it will find a way of standing on its own two legs, really. Keep it practical and keep it valuable.
That's great. I think thumbs up from Laura. Thank you. Sue, is that similar picture in the US as well?
Yes, we often have projects, that may be short term, may end up being long term with certain clients, but there's always ends up being a technology transfer and making sure the clients really are bought into what they're getting. We find that as long as you're meeting the needs of the industry, that they will continue to use that. And sometimes our handoff is to forecasting companies that will provide a continuous service. But we find that, especially in the US, to operate some of our rather delicate grid systems, they really need that situational awareness.
That's great, thank you. Yeah, so the importance of that collaborative effort early on, isn't it? So another question for the panel. What have you learned about climate services through that? So I wonder if some of the learnings have been mentioned already. Is there anything else that anyone would like to come to the discussion with on what they've learned about climate services through the project? Open the floor, fastest finger first.
Yeah, can I go again, Emily? Teen Savage speaking. Yeah, that don't as Leo pointed out, it was a 42-month project, and what we started as what we thought we were going to get as a climate service doesn't look anything like what we ended up with. You know, we started off thinking about temperatures and rainfall and how we can predict those over the coming weeks. And we ended up actually with a totally different approach, which was to do with weather types. So the Met Office did a lot of work and actually realised that it was the transition from one weather type to another weather type, which gives us an indication of the change in direction of demand. So we ended up with actually a much simpler end product than we actually expected. And, if you asked me at the beginning, I would never have guessed it would have looked like this. So yeah, don't be sort of blinkered, and we got there in the end. You know,
that's a really nice message, actually. That sounds like there must have been a lot of two-way conversation going on there to come up with a solution at the end that was different to the one anticipated. Antonio, you were new to climate services at the beginning of the project. What would be your one take-home learning point from SECLI-FIRM?
I think I want to add something about the question right before, because also I forgot to answer that for us the instrument and the tool of seasonal forecast is important tool, and regardless of skill, we can continue to use the seasonal forecast in our company, because a company like Enel cannot let slip away an instrument like this. So about the future of this instrument, for sure we will continue in this direction, but I don't know if the SECLI-FIRM team is the future? Where is the future of the SECLI-FIRM team? Just for this, I want to add this, and maybe is something that can be added to your question.
That's great, thank you. Actually, another question to you. I think that there's one in the chat here. Do you know about shared efforts to develop user-side simulation models like land and irrigation models to be used within climate services? So in terms of the SECLI-FIRM project, I think NL will have been developing their own user-side simulation, so they wouldn't have been the land and irrigation models, but maybe you can say a little bit about the sorts of models that you were developing off the back of the services you were receiving, Antonio?
Yeah, but at the moment, I don't know exactly about land and irrigation model. I don't think that there is something about, so we will working on something else, but I don't know honestly at the moment.
Okay, thank you. Sue or Laurent may have some background in these sorts of user-side model developments. Would either of you like to come in on the sort of user-side models?
Well, one thing that we do at NCAR is to build community models, such as the weather research and forecasting model, which is the most used numerical weather prediction model internationally. And the idea of building a model like that is so that it can be maintained on a website anybody can download. For very small problems, one can run it on a desktop or laptop. But if you want to run very large problems, you can also use high performance computing, multiprocessor versions to use that. And we found that, being able to provide those types of models that can either be run by a large organization. I mean, NOAA still uses that model as their primary high resolution model to run over the US, or it can be downloaded and used by many users. And the user doesn't have to be real sophisticated to learn how to set it up and continue to use it. We found that has been very popular among the energy industry folks.
So I'd agree from my own experience that there are some users who will be developing their own models off the back of the climate services, whereas others will be needing to use the climate services as they are. So Laura, I don't know if you wanted to make any comment on that yourself. You probably have some experience in that area.
From a slightly different point of view, what I want to raise is that we have complex models on the user side. For instance, for the energy sector, we do what we call resource adequacy assessment, which, for instance, on seasonal timescale consists in taking a lot of assumptions, including weather and climate assumptions, but also maintenance and shutdowns of plants and whatever you can imagine for the energy sector. And then we try to anticipate what would be the operational conditions of the system over the next 3 months, for instance. So it's a lot of information and so on and so forth. It's very complex, very time consuming in terms of computing time. And what I just want to stress is that in that process, climate scientists are often shy or even reluctant to bring their forecast, for instance, seasonal forecast, because the skill is presupposed to be very low, especially about Europe. But in practice, what is important is not the absolute skill from the meteorological point of view; it's the potential usefulness for the end user. And so you can have a slight or even very moderate skill, which is, let's say, 5% better than climatology. But once transformed and integrated into the user model, then it can bring a big added value. So once again, it emphasizes the need to really interact with the user to understand how his model works and to try to get the most of even a slight skill in the predictions.
That's great, thank you, Laurent. So there's also a question in the chat about the sustainability of climate service business in Africa. I suspect this panel is not. Sue, did you want to come in on that?
Okay, our group has not worked directly in Africa, but many of our colleagues have, especially in the hydrology part of the world. And the goal is to work with the Africans and to try to help them set up models that could be sustainable. So it certainly is doable in Africa as well, but it's a little bit different working with the end user, I believe, in that region. But some of my colleagues have been doing that very successfully.
Yeah, so there was mention of some climate services activity within Africa in the previous presentation as well. So it might be worth trying to get those questions over to those speakers as well, who may have some experience from the external side of things. Thanks for the questions. So next question, what would be useful to you moving forward? So I suppose this is largely to the end users, but perhaps to the sort of supplier end of this chain as well. So Leo, what would be your key message for what would be useful going forward from climate services?
What would be useful for the success of climate services for me is for the industry to take the journey that the SECLI-FIRM project has taken this thing on and run with it, right? So to create the demand, to build the need, and then. But I think that question was probably asked about what would we as an industry need from the audience here in terms of climate services. And so to answer that question, we're still unpacking all the various places that the climate services can help. So it can help with flooding. It can help with knowing whether or not we should change the tires on our vehicles to be well prepared, to know where the keys are for when it gets snowy and cold, to know when the rain's going to come and whether or not it's falling on wet ground. There's an awful lot of places that the climate and climate services can help the industry. At the moment, the industry is just opening its eyes to the potential here. So I'd be much better placed to answer that question in a couple of months' time. But let me think about it while this summer school is running, and maybe I can throw an answer in that's a bit more coherent midway through this journey.
That's brilliant. Thanks very much. So last few minutes of this session, if we could start to think about maybe the top tip for people starting out on climate services. So I'd quite like to go to Antonio first, actually, because he's started on the climate service journey most recently, I think. Have you got one top tip for anyone starting on that journey?
Yeah, exactly. But I totally agree with Leo and Laurent that clarify better than me a very important point. We're starting to see something, and we started to see the potential of this tool. So for me, I starting to see this translation later than Leo and Laurent, of course, and also Alberto that started this project some years ago. But I think that the climate change transition is up to become. So I totally agree with Leo and Laurent.
Thanks so much. And just to wrap things up then, perhaps we could hear from Sue and then Laura on their top tips. I think you've probably had the most experience in climate services at the table. So Sue, go ahead. What's your top tip?
Well, I think, despite all the technology that we bring to it, I think the most important aspect is being willing to listen. The end user knows more about their problem than however high trained the meteorologist is coming in. So the willingness to listen, to really forge that two-way dialogue, and to try to converge and do it together.
That's an excellent top tip. Thank you, Laurel. You're just thumbs up from Laurel there.
Yeah, of course, I can't agree more. Yeah, I can't agree more, because that's what I've been advocating for the last 10 years. I would like to say also that one important thing is that, according to my experience, in practice, I see myself only as an interface between the climate scientists and the very end users. And I think there's really a boulevard for such people who have the available skills to understand the needs, to understand the science, and to make the link between those communities. I think there's a lot of potential for jobs here.
That's a really nice place to finish. I think it's an excellent message to take away. So if I could say thank you very much to Laurent, Antonio, Leo, Ian and Sue for their contributions. It's been a fantastic panel discussion to be involved in, and please do give your reactions now with the emoji buttons. And I'll hand back over to the COGA team.
And thank you, Emily, for being such a great moderator.